Assalamu alaikum, students. So today we shall continue from the topic of the infrared spectroscopy. So basically, we had discussed what is the IR spectrum, what is the IR radiation, how do we see the concept of spectroscopy, and then what are the wave numbers, their units, and also the absorption ranges of different functional groups which are present in the tabular form. So here we will now start interpreting the structure of the organic compounds by using the values from the table, and we'll also look into different examples to study the function group. So basically, this is the table, and from this table we can find different absorption ranges of different function groups. So you will use these values to identify. One more thing which which is needed to be included here is fingerprint region. Fingerprint region is that range of 1500 to 500 per centimeter range, or roughly near the 1500 per centimeter, in which most of the absorptions or the peaks will be existing or will be present. But these lots of peaks are not of much useful for identifying the structure of the organic compound, क्योंकि यहाँ पे इतनी ज़्यादा peaks exist करती हैं that we cannot even identify that which atom or which molecule are these peaks representing. Basically, this region of, let's suppose, around 1500 per centimeter, this region indicates the impurities present in the sample, and they can also include the bending vibrations of the molecules. We had discussed in the previous class that the type of the vibrations given by the molecule are of two types majorly, the stretching and the bending. And the bending type of vibration is further classified into four more types: the wagging, rocking, zigzagging, and twisting. So this range is also indicating those vibrations which are present in the bending, but we are not more concerned with the bending type of the vibration. However, the stretching type of the vibrations are of more helpful because they can be used to identify the presence of the function groups. So we will not consider the fingerprint region to identify the function group. Now we have this spectra over here. One more thing, the presence of the hydrogen bond makes absorbance of the OH bonds in the alcohol and carboxylic acid broad. So you will see that the IR spectrum of the alcohols and carboxylic acid would include a very broad spectrum, and the range is around 3300 to 3500 per centimeter. So this is because of the presence of the hydrogen bonds in the molecule. So a broad range will be present in that case. The OH range is 3200 in case of alcohols, 3200 to 3750, and for carboxylic acid it is 2500 to 3300. Now here's the spectrum. Now for most of the cases, I have also included the name of the compound or the structure of the compound just to resemble the function groups present and the bonds present inside the molecule. Now this is an example of ethanol. Ethanol has the OH function group. We would expect that in this case there will be the peaks of the OH part, the OH bond, or you can say O bonded with H. There shall be some peaks of carbon bonded with the oxygen, indicated like this: carbon bonded with oxygen. C bonded with oxygen, and oxygen bonded with the hydrogen. So these peaks should be there. Along with that, there will also be a peak of the carbon to hydrogen bond because there are lots of carbon hydrogen bonds. So one peak should be of carbon to hydrogen. Now we need to consider the values. So using the data in the table, note the broad bands between 3200 to 3600 per centimeter in figure 22.3. Now this is figure 22.3. So you can see a broad peak is existing here, and it is a very intense peak. It is very intense and broad peak. Now this peak is indicating the OH bond of the alcohol. It could be alcohol, it could be or it could not be alcohol, because although you can see the structure here, but we have to also distinguish it from the carboxylic acid. In figure 22.3 and then in figure 18.9. In 18.9, this is the structure of carboxylic acid, and inside this structure we also find OH group. Now this OH group is showing the same broad and intense peak in the same region of 3200 to 3600 per centimeter. So this whole region is this whole peak is the peak of the OH bond. But the difference is that this one belongs to alcohol and this one belongs to carboxylic acid. How do we know that? Arising from the OH group involved in the hydrogen bond in the alcohol and in the carboxylic acid. Now, the next thing is that we should also consider the peak of the carbon to oxygen through double covalent bond, which we know as carbonyl group. So carbonyl group must also be indicated in terms of its peak, which is not present in case of the alcohol. Alcohol does not contain the carbonyl, but the carboxylic acid does contain. In fact, the carboxylic acid also contains a carbon to oxygen single covalent bond, because we can find carbon oxygen single covalent bond in the case of the structure of carboxylic acid. So these peaks are the same. The carbon oxygen peak both have the same, and hydroxyl group peak. These are also the same. But the difference between these two is the presence or the absence of the carbonyl group peak. So the IR spectrum of ethanol shows broad, strong absorption around 3400 per centimeter. The 34 per 100 centimeter peak is this one on the slide right of this broad peak. Now this peak is indicating the CH bond. Since we can see from the table, the value of the CH is over here. In case of alkane, it is 296222853, almost near to the 3400. The absorption at 300 is characteristic of the CH bond. All right. Basically, in case of the OH group, the presence of the OH in this case is at 3400. 3400 indicates the pH peak of the OH, the peak of the OH, whereas the value around 3000 indicates the peak of the CH bond. This goes to the CH bond. Now, that's the case here. The strong absorption peak around 1000 per centimeter results from the CO single bond. Now, CO single bond in case of the alcohol is present here, 1000 per centimeter. Now, if we look for the carboxylic acid, then we do not see the peak of the CH bond over here because it is not that much dominant here. लेकिन जो चीज इसमें ज्यादा prominent है, that is the carbonyl group peak, which is not apparently our present, which is not apparent here, which is not present here. The IR spectrum with ethanoic acid shows a medium strong broad absorption of 25 to 3000 per centimeter, characteristic of the OH group in carboxylic acid. a strong absorption at 1700 per centimeter characteristic of the carbonyl group. So which peak is clearly differentiating them? The carbonyl group peak at the value of 1700 per centimeter, which we can find here. This is the one which is not present in case of the alcohol. Around 1700, this is the range. So it is not a sharp intense peak present in this region of 1700 per centimeter. Now we look into more peaks. Now this one belongs to the ester, ethyl ethanoate, and this one belongs to an amine compound. Now in case of ester, you will see the presence of the CO bond, the presence of the carbonyl bond, and also CH bonds are there. So CO bond is should also be again present in the range of 1710 to 1750 per centimeter. So that's the peak which we can see over here. So this is indicating the carbonyl group. Now about the CO peak. We said that CO peak was present in the range of 1000 per centimeter in this molecule. 1000 per centimeter of CO bond. So in case of ester, yes, there is a peak of the CO bond over here around 1000 per centimeter. This is very intense with this one. So CO bond belongs to this peak. So that's how we can find that this is the ester compound. Now the next one is the amine. For amine, the absorption peak or the absorption range is of 3300 to 3500 per centimeter. Now if we look over here, 33 to 3500 is a broad peak over here. 33 to 3500, the whole broad peak belongs to the amine group. Now you can also resemble this peak, this intense broad peak, with the presence of the OH group over here. But the difference between these two is that we also have a carbonyl group peak over here, which is indicating the presence of the carboxylic acid. But the same carbonyl group is not present in case of this compound because it is an amine compound. So that helps us to differentiate between the amine compound and the carboxylic acid. Here, this is not that much intense peak, which should be there for in case of the carbonyl group. This is not the peak of the carbonyl part. So that's why it is not the carboxylic acid. Now this IR spectrum belongs to the alcohol. So the same thing is here. Alcohol must have the OH bond peak around 3200 to 3500 per centimeter range. For the CH, we have value near the 3000 per centimeter, which is an intense peak slightly. And then we have the CO bond. This CO bond belongs to the stretching. But this CH is not the right one which we need because this belongs to the bending vibration. This one belongs to bending and this belongs to the stretching. The stretching vibration of the CH. So you will when you will go through multiple IR spectra of the same type of the functional group, then you will be able to recognize just by looking at the IR spectrum that this must contain the alcoholic function group or the carboxylic acid or the aldehyde, ketone, etc. Now this is another table for the same purpose of identifying the function groups. Now in this case, we have the function. Now these two are the IR spectra of the same organic compound, that is the ethanol. So ethanol and ethanol, but be mindful that these two spectra are taken from different source books. You can clearly see here that both are more or less similar. You can find a lot of resemblance between these two peaks, although they are taken from different source books. You can find this very intense peak over here around 1700 per centimeter. Now this one is belonging to the carbonyl group. So which now from this peak we can consider that that can be a ketone it could be an aldehyde, it could be a carboxylic acid, or it could be an ester. So we have to use this same part with this molecules, both have the same because this are the same compound. Now ethanol has also the presence of the CH bonds. Now CH bonds of the stretching vibration. All right, just because it has only the intense peak of the carbonyl bond on this range, we should now consider that it should be the carboxylic acid, but it does not contain the OH group here. If we consider that it must be an ester, then it does not contain the CO bond here, neither here or not here. So from here, we do conclude that it is only the aldehyde functional group, and also we can also use the table to find the presence of CO in case of the ketone. So for ketone, the value is 1700 to 1720, and for aldehyde is 1720 to 1740. Now, although it does not indicate very much accurately at which point does it contain, because this literature is just to tell you the type of the peaks which are present for different functional groups, but not using clear information that at which point is the peak is lying on. So we'll go through more examples to see for the exact point of the peaks on the spectrum. Now this compound is basically the IR spectrum of ethanol. So again, we will see the presence of the OH peak. So this is broad peak indicates the alcoholic part. Now this sharp peak indicates the CH part. And then we have the CO bond peak over here. So if you match this IR spectrum with the already covered alcohol IR spectrum over here, so you can see they are very much similar. This one is also belongs to an alcohol, although this one is a hexane 1-ol. So there is a difference on the basis of the carbon chain, but the peaks are still very much similar to each other. They are most similar. Now the next peak over here. So in this peak, we can find this belongs to the carboxylic acid. So the broad peak of the OH bond is present here, and this intense peak is linking with the carbonyl group. This is the IR spectrum of the carboxylic acid, but this is propanoic acid. So you can now compare these two peaks at the same time. They are still matching with each other, and they are taken from different resource books. This one belongs to another source book. This one belongs to another resource book. So you can find almost similar matching here. And in the same way, we have the alcohol function IR spectra, and they are also resembling with each other. We can find the presence of the CO bond over here, the CH bond, and the presence of the OH peak, which is a broad peak. And this compound belongs to the carboxylic acid, and this is propanoic acid. This is also propanoic acid, again taken from another resource book. Now these three peaks, these three, 1, 2, and 3, all of these three peaks are basically basically indicating the carboxylic acid. This one is propanoic acid, this one is propanoic acid, and this one is butanoic acid. All these three peaks are taken from different resource books. So you can find a clear resemblance in their pattern of peaks. Now this one has and one more thing. This is also the peak of the carboxylic acid mentioned over here, propanoic acid. So all of them have more or less similar type of the peaks. Now this one has kind of different spectra. This compound is basically containing two different functional groups, the alcoholic functional group and the carbon-carbon double bond functional group. Now we should also check the we should verify that could be valid. So the OH peak is present here, broad peak is present here, and then carbon-carbon double bond. So for carbon-carbon double bond, we need to look into the table again to find the value for absorption range. So carbon-carbon double bond stretching value for alkenes is present in 1669 to 1645. 1669 to 1645. So here, peak of 1665 to 1645. This one. This could we can consider here that this is the peak of the carbon-carbon double bond. We can also check from the other table, are they showing the same values? For carbon-carbon double bond, 1669 to 1645. So these peaks are there, but just to make it more clear whether it should give a short, an intense peak or weak peak. So carbon-carbon double bond, you have to check from here. This one. Carbon-carbon double bond is a stretching peak and they are of the medium type. So you have to make use of this table as well just to make it clear that it should match with the IR spectrum which you are looking at. So alkene peak was the peak of the alkene is basically of medium size. So yes, we do see that the peak in the intensity of the peak is of medium type over here. In this case, medium type, not very intense and not very weak. तो इस तरह से we are checking all the functional groups from the IR spectra. So here they are taking a question that you have to identify that this IR spectrum should be one of these three compounds. It could be 2-butylamine, it could be butanoic acid or it could be butanol. तो ये चीज चेक करने के लिए कि किसको बिलोंग करती है, इस काम के लिए you have to consider different bondings which must be present in the compound. अगर हमारे पास ब्यूटाइल अमीन होगा तो उसमें जो bonds present हो सकते हैं, कार्बन कार्बन सिंगल covalent bond, कार्बन to hydrogen single covalent bond, कार्बन to nitrogen and NH. अगर ब्यूटानाइक एसिड होगा तो उनमें ये तमाम बॉन्डिंग्स एग्जिस्ट करेंगी. अगर ब्यूटानल हुआ तो उसमें ये तमाम बॉन्डिंग्स एग्जिस्ट करेंगी. अब हम इस स्पेक्ट्रा को इनसे मैच करेंगे. So all the three substances have a CH bond which is the strong absorption around 3000 per centimeter. तो 3000 per centimeter में strong absorption देखने को मिल रही है. So that is basically present in all of them. Butanol and butanoic acid में हमारे पास कार्बोनाइल ग्रुप भी प्रेजेंट होना चाहिए. और अगर हम यहाँ पर देखें तो 1700 के अराउंड एक इंटेंस शार्प पीक होनी चाहिए which is not here, absent. There is no carbon, there is no peak for carbonyl group present here. So from here we can clearly say that it does not belong to both aldehyde or the carboxylic acid. दोनों को ही belong नहीं कर रही और carboxylic acid में in fact OH की broad peak भी यहाँ पे absent है. There is no presence of that peak over here. So the OH bond in butanoic would produce, this is not present. तो OH group की peak भी यहाँ पे present नहीं है. The sample is not butanoic acid. The NH bond is 2-butylamine would give a weak absorption at 3300 to 3500 per centimeter. So weak peak 3300 to 3500 आपको यहाँ पर मिलेगी, this peak. So this peak belongs to the NH bond of the amine group. So you can also check this IR spectra with the already covered example of amine. We had discussed one such example of amine group over here. So this is example in which we had discussed the amine group. So 3300 to 3500 But in this case, you can find that the peak is basically a broad peak. So why is that so? It is because there could be some differences on the basis of the different mixtures in which this compound is present. So different compounds can have some kind of effect on the actual shape of the peak. But in this case, you can see that it is a different structure. It is 2-butyl amine structure. So on this basis, there could be some differences on the basis of the peak which we can see here. Another example, this example includes the nitrile group. So nitrile group must be indicated here in terms of its absorption range. So this is the absorption range for the C triple bonded N. So this one belongs to the CH bond of the alkane, and the nitrile group is present at 2249 per centimeter. Now we can also check its range from the table, nitrile group from the table. So now in this table, the nitrile is present at 2200 to 2250, and the value which we just saw in that book was 2249. So yes, it belongs to nitrile functional group, and the peak is of weak type. It is not an intense peak. So over here, 2249, very intense peak, but here you can see it is of the strong type. Why do we find a clash in the reported values of the table, reported terms of the in the table, and actual shown on the spectrum? Again, reason यही है कि जो molecules होते हैं उनके ऊपर different जो substances होते हैं in the same mixture, they have an effect on their structure. That's why we see uh, some different structures. Now this one belongs to the alcohol, which is a propanol. So you can see again the broad peak is of the OH, this sharp intense peak is of the CH, and the CO peak is present here. You can again compare with the previously covered IR spectra of the alcohols, and this one belongs to the simple compound of butane. So only CH bond is very dominant here, and no other peak could be actually seen to be very intense. This IRP belongs to the ketone. So in case of ketone, you have to check from the table at which position the carbonyl bond belongs. It is mostly in the range of the 1700 to 1750 per centimeter. So we can find this intense peak, which is an indication of the carbonyl group. So if the value is already given, or it is very much cleared from the table or from the graph that the value is at the right range of the ketone, so we can verify it. And now this one, alcohol. So there are most of the IR spectra of alcohols and the carboxylic acids, and over here both T and U show a carbonyl absorption in their spectra at about 1700 to 1800 per centimeter, and a CO absorption at about 1250. So both have them the same type of the CO bond. T shows the broad hydrogen bond and OH bond from 3300 to 25, which U shows no OH bond at all. So you can find a broad peak in case of T, which is not present in case of the U. So we can say that the T is basically the carboxylic acid, since it has both carbonyl group and the OH group, whereas U could be the ester in which there is no presence of the OH group. And then we have some more examples. I have mentioned all the names of the compounds or the structure of the compounds just above the IR spectra so that you can easily cross check with other molecules and you can easily learn how they are basically indicating or validating the IR spectra. Alcohol, ketone, and ketone. So both of these are ketone. These two. They are taken from the past papers. All these graphs are taken from the past papers. So you can find that this ketone and this ketone, they are slightly different from each other, and to some extent they are also similar to each other. This is of 4 carbon atom, that one is for 3 carbon atoms. And this one contains 2 functional groups of OH. So there are 2 alcoholic functional groups in this compound. This is also the alcoholic compound, but this has clear broad range, but this has slightly different broad range because it contains a benzene ring. Carboxylic acid over here, and this one has all the carboxylic groups present, all the alcoholic functional groups present here, the hydroxy groups. So you can basically go through different IR spectra to just to check your values from the table and to learn how the functional group is basically indicated in terms of its peaks in the IR spectra. So that's all for the IR spectroscopy topic. We have finished our IR spectroscopy over here. So in our next class, we'll start the mass spectrometry, which shall be the last topic of our AS chemistry. So students, that's all. Take care and Allah Hafiz everyone.